रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अऊज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम सुब्हानल्लाहि वल्हम्दुलिल्लाहि वला इलाहा इल्लल्लाहु वल्लाहु अकबर वला हौला वला कुव्वता इल्ला बिल्लाहिल अलिय्यिल अज़ीम अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मद कमा सल्लैता अला इब्राहीम व अला आलि इब्राहीम इन्नका हमीदुम मजीद. Okay guys, in this video I will derive a new algebraic formula for calculating the factorial of any number, real or complex, positive, negative, complex, whatever. Okay, the formula looks like this: n factorial is equal to blah 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 blah, and s is greater than equal to 0 less than infinity. Okay, so I will use a well-known formula for the gamma function or the n factorial in the form of this integral, as you guys all know. But I will introduce a tuning factor s called Tahir tuning factor in the above formula as below. Why I call it a tuning factor? Because it will tune the two parts of the integral. It will keep on increasing and decreasing the value of the areas in these two terms. Okay, then eventually we will find the optimal value of s that can give us the most number of decimal places, correct accuracy. Okay, so we will break up the integral into two parts, 0 to s and s to infinity. Okay, so I will call this the lower series and this the upper series. Okay, so we'll put this value of e minus t expansion summation in here in the lower series. It becomes like this. So take the tn inside and take the summation and the constant outside, and eventually when we integrate it we get this one. So the upper series becomes as follows after integration. And now we will do the analysis of the upper series. Upper series is this series. We will do the analysis of this one by using the integration by parts. Okay, so we have u tn dv equal to e minus e. That's the usual traditional way of doing the integration by parts. So we get this one. Okay, so we will evaluate this expression at the upper limit of the integral infinity. So we write this one as this one, and then we do successive differentiation using L'Hopital rule of the numerator and the denominator with respect to t, the variable of differentiation. Okay, so we will consider n as non-negative integer or positive integer. So its derivatives will end up in n factorial. So the derivative of et, they will not end up in anything, they will remain et. So when we put t tends to infinity, here we get 0, because the denominator becomes a very big number. Okay, so we have this one as this one. Okay, so this is the value at the lower limit s of this, because at the upper limit it goes to 0. So minus cancel with this minus, so we get this one. Okay, now applying successive integration by parts, I obtain as below. When you apply further integration, you get this sequence, this pattern. So take common Sn over Es, you get this pattern. So finally we obtain Tahir Factorial Formula in this formation in history for the first time as below. So these two parts existed in classical literature, but they were never put together to make this formula. They did not exist in this form, but similar form they exist in under the umbrella of gamma stuff, gamma function stuff. Okay, so I have put these two together in a factorial form. They existed in gamma notation, but never in factorial form. So this is the algebraic formula where s is greater than 0 less than infinity. So this is the algebraic formula for the calculation of factorial. Tahir factorial formula is true to the core for the entire range of factorials that exist. So whatever form factorial you can find with any classical method, you can find with this. The first term is the lower series, and the first term is the lower series. The first term is the lower series, the second term is the upper series. And it's an alternating convergent series, and the second term is the upper series and is an asymptotic series. So this one is an asymptotic series, so this one is a convergent series. This one is an asymptotic series, just like in Euler-Maclaurin formula. The term containing the parts term containing the odd derivatives is always an asymptotic series, or in other words, the divergence of the convergent series. Like when the terms grow bigger after a certain pattern, then the series become divergent, or it's an asymptotic series. Tahir Factorial Formula combines these two terms explicitly. Well, it's only my formula that combines these two terms. No one has ever combined these two terms together. They could not think of this thing like that. So it uses factorial language, no gamma function, just a factorial language. The sum of the two terms is marked as a factorial of a number for the first time in history. So the sum of these two terms is marked by me to be the factorial of the number n for the first time in history. S is free and emphasized. So S is free to choose and emphasize, and does not give any approximate things. Its tail is used in exact cancellation, 0 factorial. If you calculate 0 factorial or 1 factorial with my formulation, you will see that this tail exactly cancels this. In the previous literature, in the classical literature, this term has been said as approximate, but whereas it's not approximate, it exactly cancels this term to produce the value of 1 and 1 for both 0 factorial and 1 factorial. Whereas in the classical results, the tail was seen as approximate. This packaging is now a standard. This packaging of mine is now a standard. It's now a purely algebraic factorial formula. The sum gives exact value. So if you use infinite precision screens with infinite digits, so it will always converge to the exact value. So S, where a model has been designed for S, you can use n factorial plus 1.5 square root of n factorial plus 2. So why I used the absolute value here? Because you can use my formula to get the values of the negative factorials as well, except -1, -2, -3, at which the one of the series explodes to 0. It's a pole, creates a pole with infinity in the 0 in the denominator. Okay, so this one is true for all n real and complex. So you can use this simple. The coefficients are simple too, 1.5 and the square root, and it's very simple. You can use this for any n to calculate the factorial. Okay guys, instability in cancelling up to a certain point for the alternating series, the convergent alternating series, converging alternating series, the instability in cancelling up to a certain point where you start getting a convergent value is a characteristic feature of an alternating series and not its flow. Subhanallah walhamdulillah wala ilaha illallah wallahu akbar wala hawla wala quwwata illa billah al-aliyyil azim. Allahumma sibna hisaban yasira. Allahumma salli ala Muhammad wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Thanks for watching.